Hello everyone in pre-calc. I know we're in this last week now. I've gotten several requests for help on graphing and the unit circle, and in some of my conversations with some of you, we've come up with some techniques using Desmos. So I'm going to share that with you today. I'm going to move along as quick as I can. This is something I just came up with this morning as an idea, so hopefully this all works for you. So graphing the unit circle using Desmos, and then we're also going to use the Desmos tool to graph any trig function. So we'll see the connection between triangles, the unit circle, and graphs of sine, cosine, and various trig functions. So let's start by getting a unit circle, and we can do that. It's also going to connect trigonometry to algebra by this function. Now this works in Desmos. It won't work very well on your handheld graphing calculator because you need to be able to graph a non-function, right? X squared plus y squared arrow over equals 1. There we have it. It's the unit circle. Desmos will graph it. What we want to do is we want to zoom in a little bit. There, that's pretty good. And you notice we can go along this unit circle, and one of the definitions for trigonometry is that the x-coordinate of a point on the unit circle is the cosine of x, and the y-coordinate is the sine of that angle. Now we're gonna actually build the angles in here, but this is what we start with: x squared plus y squared equals 1, where x is cosine x, and the y-coordinate is also sine x, or sine, we'll call it sine theta, right? Sine of the angle that comes from here, and we're going to put in a few angles, okay? But what I want to show you is the 90-degree angles, and this is what we often use if we're trying to construct a graph, is these intersections of the unit circle with the various axes. We've got 1 and 0, 0 and 1, negative 1 and 0, and 0 and negative 1. So this is 0, this is 90 degrees, pi over 2. This is 180 degrees, pi. This is 270 degrees, 3 pi over 2. I have to think a little bit. And over here, 360 degrees, or 2 pi. Okay, so that's the unit circle. Now, to connect this to what the activity we were doing earlier, remember when we were doing this triangle, we measured the 45 degree. This measured out at 1 decimeter, 1.0. When we measured this side, we came up with about 0.71, and then I told you the exact value should be 0.707, and I gave you this exact value of square root of 2 over 2. And if you take the square root of 2 divided by 2, you get 0.707, and a bunch of other things, right? It keeps going. So I don't want to spend too much time on how I got this. It's using the Pythagorean theorem and trigonometry, and that's something we can do. But if we just accept that this is a representation, this is a number, square root of 2 over 2 is a number that is the same as, or pretty close at least, we say approximately 0.707, and so forth. And we can get these exact values and such, but this is what we're going to work with. Now, what I want you to think of is, since we're going to connect this to Desmos and graphing, think of this hypotenuse as a line. So what are these two sides? Well, this could be considered, if we're thinking algebra, as rise. And that's the thing with math, that everything can be more than one thing, and we're trying to connect multiple things. And oftentimes when we learn something new, we think, oh, it can only be one thing, and we're trying to see the one thing it is. But especially in trigonometry, there's multiple things that it can be. So rise over run. So the slope of this line is going to be square root of 2 over 2, that's the rise, right, divided by square root of 2 over 2. Okay, so that's going to be our slope for the line. I'm going to use that in Desmos, and we're going to see how it makes our unit circle for us. Okay. Down here, we also, the other special triangle we had was a 30-60, and these should have little degree marks. I'm going to fix this up. I used Photoshop for this, and I couldn't find that degree, but we'll get that fixed. Remember, we measured this. This was 1.0. This side was actually the easier one to get. It actually ended up being 0.5 exactly, which is 1/2. 1/2. The one on the adjacent side, this 30 degrees, ended up being 0.87 we measured, which is actually 0.66. This is square root of 3 over 2. Okay, so these are kind of angle or measurements that we need to remember, and again, in that video, hopefully it helped provide some ways to understand it. So when we view the line this way, with a 30-degree angle to the x-axis, this is our rise. 1/2 is our rise, so we'll do a 30-degree. Our slope will be 1/2 over square root of 3, 2. And if we want the 60 degrees, remember, I'm not going to physically do it, but we'd have to flip it. And so the sides change, the opposite and adjacent. Anyway, for a 60-degree angle, and mostly I just want you to see, it's going to be the square root of 3 over 2 is the rise, and the 1/2 is the run. Okay, so I'm going to put these in as equations, y equals the slope times x, and you're going to see what happens. And what I'm trying to let you see is that if you remember a few things, you can actually create everything else. So y equals, now you could just put x, right, there it is, but I want to emphasize this. This is going to be, let me put this thing here. We're going to do the square root of 2 and get outside of the square root, divided by 2, and then get outside of that. I'm going to divide that fraction by the square root of 2, get outside of, not too far outside, just outside, divided by 2. And again, that is 1, and then x. There's my 45-degree angle here, and look at this. When I click here, I get my x-coordinate as my cosine of 45 degrees, cosine of pi over 4, connecting all these things, and the y is the sine of 45 degrees. Okay, let's go with y equals, let's do a 30-degree. Remember, that is going to be 1 divided by 2. Let's do it this way, divided by square root of 3, and then again you have to kind of click out here a little bit, divided by 2. So that's that slope, x. That's the 30-degree angle, and again here 0.866, 0.5. These are the things we measured, and you could visualize here the triangle sitting right in there from that activity we did. This could be another one. So, and the nice thing with Desmos, you can mark these here. You can create your own unit circle, and we get the back side. Now this 30 degrees, if we were to go all the way around to here, see this one, notice it's the same. So that's 180 plus 30, that's going to be 210. So we get that, and you can see the negative and the negative. So cosine is negative, sine is negative. So we're kind of getting everything here. The last one we need for the first quadrant at least is y equals, and now we're going to flip. So we're going to go square root of 3 divided by 2. And then we're going to click out here because then I want to divide that fraction by 1/2. 1 divided by 2. There we go. And you kind of see what it is. We put the x and we get our line here. That's our 60 degrees, and look what we got. And again, we can get that same value back here, 60 degrees from the bottom side, which would be 180 plus 60. And again, we have to connect all these various things. How do we get the other ones? Well, if you wanted to, this one's not too bad. You can copy, well, see, maybe a Control C, and then let's see if I can Control V. No, mine doesn't let me do that. That's, well, if I can copy it, which it won't let me, you can put a negative in front of that, and maybe I'll just copy this part. Control C. Let's try this. Y equals, let's see if I can paste. No, it's, I just started using a Mac again, and let's see, maybe in Desmos I can actually copy. Let's try this. And then try a paste. Hey, that worked. Okay. And then what I'm going to do is I'm going to put, I get in front of that, and I'm just going to put a negative. Where's my negative? Not a subtraction. Well, maybe it'll do. So see, I could come back the other way, and that gives me second quadrant. Notice cosine is negative, sine is positive. Fourth quadrant over here, cosine is positive, sine is negative. So I could fill in those, but and then you'd have your complete unit circle. Okay, and you can click on these intersections, and then if you wanted to, you could print this, right? So these are the important ones. Okay, so that's the main thing of, that's where the unit circle comes from. Now, when we go to graph, we're graphing functions of, let me come back here. We're going to graph some function like y equals sine of theta. So we got the angle. Now, in this case, the input, theta, if you want sine x, the x coordinate is actually an angle measurement. The y is the sine. Okay, so it's the y coordinate that comes from the unit circle. We're actually on a different set of axes. Here, x is a number, right? So it's just these. It's just a regular coordinate system. These are what's getting graphed, x squared plus y squared. When we switch over to graphing trig functions, then the x-axis actually becomes the place. The input is an angle measurement, not a number, not a measurement of a triangle, not a measurement of a side, but a measurement of an angle. If that makes sense, and I'm hoping it does. And again, I look forward to any feedback you can provide me. So these special angles are actually not very helpful, because look at how can you graph 0.707. We're not going to graph that very good. But if I turn these off and get them sort of out of the way, the parts that you see that are going to be the easiest to graph are these ones, because these 4 points, you got 1 and 0, 0 and 1. So these are easy to graph. So those are the ones we use. So when we're creating the graphs of sine and cosine and various other things, we focus on 0, pi over 2, pi, 3 pi over 2, and 2 pi. So now I want to move on. I want to clear things out, and I actually want to graph something. So I'm gonna, let's just delete all this. It's a lot of work, but we can redo it. And so what I want to graph, before I start graphing though, since the x is going to be angle measurements in pi, what I want to do is I click on this graph settings, and I'm going to take my x-axis and I'm going to say, let's go from 4 pi, and just type in the word pi and it turns it to pi. A student and I were working together and we figured this out. Actually, we don't want to go, but we want to go from negative 4 pi to positive 4 pi. So that gets us a few times around the circle, and then we want our step to be pi. This is and notice now, look at that x-axis, it's so beautiful. Pi over 2, pi, 3 pi, so forth. Okay, so our x-axis is now set up to report back to us. So if I want to graph something like y equals sine of x, this is what I get. And I'm zoomed in. I can zoom in or zoom out a little bit if you want. But look at this. Here's 0, 0. So when the angle is 0, the sine of x, the sine of 0 is 0. And then, so these are the y coordinates. When the angle is pi over 2, and I guess I wish I would have saved that other one. We could go back and forth. The y coordinate is 1. When the angle is, oh, I missed one here. When the angle is pi, the y coordinate was 0. And then 3 pi over 2, that gave us a y coordinate of -1. And then when we get one whole period, so we went up, down, when we get to 2 pi again, we're back to 0. And it all starts and repeats. Okay, if you were to graph cosine of x, and we could do this on the same axes, or same, the same graph itself, you see that the values are just kind of shifted. It really is the same overall pattern, but instead of starting at 0, it starts at 1. So when the angle is 0 degrees, 0 radians, cosine is going to be 1. When we're at pi over 2, remember the cosine was 0. And so you can kind of do that. The nice thing is now you can graph any trig function this way. So I think one of the examples had something like y equals sine of 2/3 x, 2/3 theta. And when you do that, notice it's a little different where they are, but what we're looking is if you take 2/3, if you take this 2/3 times 3 pi over 4, what do you get? You get pi over 2, because at pi over 2, the sine is 1. Now 0 is nice because 0 times anything is 0, so that stays. But this 3 pi over 2, remember on the standard curve, the last one, this would have been pi. So these things all move, but look at this. You can at least highlight it, and it's giving you the values in radian measure. So the activities in Alex that call for these radian measures, you've got them. Okay, I'm going to stop here. I think that's probably enough to get you started. The main thing I want to show you is the graph settings. If you change this step by pi, and remember, just type in pi and you get the pi. And notice it changed it from -8 to 8 now. You can because I zoomed out a little bit. So that's kind of cool. I hadn't thought about that. When I zoom in, it's now zooming in terms of pi. So it's helping my Desmos graph to really be a good trig tool. So I hope this was helpful. Give me some feedback and I'll improve it. I'm going to take a look at the problem set and try to give some guidance on how to go about that using Desmos, using these tools. Keep moving forward. We can all be successful only when we're all successful, right? It's not about one of us making it, or we all got to make it. So hang in there, keep pushing forward. We're near the end, but we can all make it, and we can understand it. Trig is one of those topics where it seems really confusing until in an instant you'll start to connect all the different things we've been doing. I think of the Karate Kid, right? Wash the car, wax on, wax off. If you remember that movie, all of a sudden he realizes he's been getting karate skills. I think that will happen for you soon. hopefully soon, and you'll just all of a sudden say, wow, this trig is cool. So anyway, keep it up, give me feedback, and we'll continue this conversation. Thank you very much. Oh, I guess I could show you my face again. So graphing with Desmos. If there's something that isn't clear or you want to see another example, send it to me, and in between my other classes and such, we'll again make a quick video and kind of have this open conversation. Thank you.